Hello everybody and welcome back to the Super Helpful IT Guy. Today I'm going to explain to you the components of a computer. What makes a computer happen, what they do, what the components are, and we're going to go over it. So here we go. First component of a computer, well you have the case, but I didn't put that. Anyway, what's in a desktop computer? Well, a lot of things actually. The first thing that we're going to look at is the motherboard. This right here is the motherboard. It has a bunch of slots, a bunch of pockets, a bunch of sockets, a bunch of junk. So what the motherboard does is it facilitates the transfer of data and power to the other components. So if you want to think of it in a physical type of environment, you might think of it as your workshop if you're a woodworker or a carpenter. It's like your workshop. Everything you need is there. It's just enclosed in one spot, so it's your environment that your data and power transfer through. Next component is our CPU, our central processing unit, and that's you. That's the worker. That's the one that does all the calculations. That's the one that does all the data processing. So that's you. That's the worker in the workshop. That's going to do the bulk load of all your processing. It goes in a little a socket in the motherboard. Depending on who makes the motherboard, you might have to get a different CPU. The reason why I showed you motherboard and CPU first is when you're building a computer, when you're buying the components, those are the two things that you look at first to make sure that they are on the same page, that they're compatible with each other. And once you figure out your motherboard and your CPU, the rest of it will kind of come a little bit easier. Speaking of the rest, the next is your RAM, your random access memory. So your random access memory is like your workbench. So anytime that you say, hey, my computer's going slow, what can I do to speed it up? You'll get a lot of people that say, jokingly, download more RAM. Because the more RAM you have, it's like the bigger workbench that you have. Like up here, this is like a 4 to 8 gigabyte RAM computer. You have a little bit of space. You can bring your tools out and work on it. But this is what you work out of. You don't work out of your hard drive. You don't work out of your motherboard. What you work out of is your RAM. Your RAM is what it's what holds all your work, all your applications while they're in use. Kind of like a workbench. It holds all your tools, holds all your projects. So this is like a 4 to 8 gigabyte RAM workbench. This is like a 32 to 64. You have a lot more room. You can have a lot more projects going on at one time, the more RAM you have. And some RAM require a heatsink. So if you'll notice, it's still the same underneath it. You still have your edge connectors. So let's look back at this one. You still have your edge connectors and these little black chips. That's what's actually holding your data as you're working on it. So sometimes RAM gets hot and they put a heat sink on it with these fins to let air flow through, and it dissipates the heat and it keeps it a little bit more cool. Next up is your hard drive. Your hard drive comes in many different form factors. You have a mechanical hard drive. It's got a spinning platter inside that works like a record player, if you've ever seen one. It has a needle, a read-write head that goes back and forth like the needle on a record player, and it reads and writes data to a spinning platter. This is relatively slow compared to what is up to date now. Now we have solid-state drives, which come in, again, more form factors. You have a solid-state drive that requires the SATA cables, the SATA data, and the SATA power. But then you have the M.2 drives, which work directly off of your motherboard. It's directly connected to it with these edge connectors, and this is a lot faster than the traditional hard drive. So you want to think of your hard drives as kind of like your toolbox. If your RAM is your workbench, your hard drive is your toolbox, because this is where all of your data is stored. When you turn off your computer, when you turn it back on, what your computer does is it loads all your tools. It loads Windows or Linux, whatever you're using. It loads your operating system. It loads different tools onto your workbench so that you can use it and work with it. So your hard drive is like a toolbox. It holds all your files and folders just like it would hold all your tools and materials. Next up, we have the power supply. This one is kind of self-explanatory. It provides power to the rest of the computer. Here is your P1 connector. This connects to most motherboards, unless you have some kind of proprietary type motherboard in a desktop. You will always see this P1 connector. This happens to be a semi-modular power supply. So modular means that you can change it. So you have these ports that you can plug and unplug cables. So if you don't need them, cable management is a lot better. Then you have the non-modular power supplies that everything is hardwired into it and you can't change it. So you have a mess of cables whether you need them or not. So power supply, it does exactly what it says. It supplies power. Next is your graphics processing unit, your GPU. Some people call it a graphics card. What this does is it plugs into your motherboard and it processes the graphics. It has its own built-in RAM and things like that. So it's kind of like having a little helper inside your workshop. So you're taking care, like the CPU is taking care of all the other calculations. It's running the, it's running the game in the background, all this stuff. And then the graphics card, that does the graphics. That has its own little job, and that's what it does. A lot of games nowadays require graphics cards. So yes, most computers nowadays, when you build your own for home use, you'll have a graphics card. Now some CPUs, some workers in the work shed, they do everything anyway. There's certain CPUs that do the graphics processing and you don't need a graphics card. However, it's not as high end as having a graphics card. And that's what's in a desktop computer. I hope you guys enjoyed this presentation. I hope it helps you a little bit with your understanding. At least this is how I understand it. If you guys think of it in a different way, please feel free to comment. Feel free to tell me how you think of all these components. Now, I will say that there is a lot more to it than what I just went through. For instance, CPUs work at different speeds. There's overclocking. RAM, there's also overclocking for RAM. There's different speeds of RAM. There's different form factors of RAM. There's different versions of it, like you have DDR2, 3, 4, and 5 is coming out now. Different hard drives. There's different storage capacities. There's different speeds in your hard drive. If you look up Western Digital is a good one. If you look up Western Digital color codes, it'll tell you what the colors are and what they mean. But I don't want to overwhelm you. I just want to get you a kind of a groundwork before you start looking at stuff. So yeah, that's it. That's what makes up a computer. Once you have all those components in and working, that's a computer. It's as simple as that. It's really not as difficult as a lot of people think it is. I hope this helped you out. You guys have a great day, and we'll see y'all next time.